Welcome to our video solution for our 7th and final question from Superquiz 1. In this problem, we're given a set S and an equivalence relation, call it E, on the set S. We're going to use this traditional square bracket notation to denote the equivalent class of an element, modulo this equivalence relation E. And we're going to assume that we have two elements of the set S that don't have the same equivalence class. So there's a little hint down at the bottom that reminds you, this is one of the problems that we worked on during the week, which is that two elements have the same equivalence class if and only if they are related. So when we say that A and B do not have the same equivalence class, we know that they are not related. So let's just record that right at the beginning. So since the class of A is not equal to the class of B, we have A comma B is not an element of E. Okay, now what are we trying to prove? Right? Well, we want to prove that if you look at the equivalence classes, they're just subsets of S, and you look at their intersection, there's nothing in common, right? The intersection is the empty set. So this is key in showing that an equivalence relation will partition your set into disjoint subsets. All right. So the way we'll try to prove this here is by contradiction. Let's assume there is an element in the intersection. So we'll do a proof by contradiction. So assume, let's say we'll call it X. Assume an element X is in the intersection of the classes of A and B. Okay, well, we know with intersections, that means you are in each set. Right? So it follows that X is in the class of A and X is in the class of B. Now, what does it mean to be in the equivalence class of A? It means that you're related to A. So thus, X comma A is an element of E. And, well, we do the same thing here. X comma B is an element of E. All right, but of course, E is an equivalence relation. And so this down here also tells us that A comma X is an element of E. And so I now have that A comma X is in E and X comma B is in E. Okay, by the transitivity of E. So remember, that's an equivalence relation, so it's transitive. So the transitivity of E, what do we conclude? Well, if AX is in E and XB is in E, then we know that A comma B is in E. And this is a contradiction because look at what we had up above. A comma B is not in E because A and B are not the same equivalence class. Okay, so this is a contradiction. Where did that contradiction come from? It came from our assumption that we had some element that lied in the intersection. Therefore, that assumption must be false. Thus, the intersection of the class of A and the class of B must be empty. And that completes the proof.